for both SS1, SS2 and SS3 students. I welcome you all my participants. Today, let's study physics. Now, remember in our previous class, we talked about the reflection of light at plane mirror surfaces. Remember under it, we talked about the types of reflection, where we discussed the difference between regular and irregular or diffuse deflection. We equally talked about the laws of reflection. Remember what I told you concerning a law, you must state it correctly. And we have two laws of reflection. The first one states that the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. Remember, we demonstrated it practically. We equally have the second law of reflection, which says that the angle of incidence I is equal to the angle of reflection R. We equally talked about the principles of reversibility of light that told us that the paths of a light ray is what? Reversible. Finally, we talked about the characteristics of image formed by a plane mirror, which we demonstrated. We listed the characteristics: that the image is visual. We said that the image is as far behind the mirror as the object is in front of the mirror. We said that the image is the same size as the object. We said that the image is upright. The image is equally laterally what? Inverted. Now today, we're going to look at continuation of that reflection of light at plane mirror surfaces. Now we are going to look at today the multiple image in plane mirror. Formation of multiple image in a plane mirror. We find out that multiple images can be formed in a plane mirror. But before we continue, let's look at our specific objectives. By the end of this lesson, my students will be able to, number one, mention the number of images formed when mirrors are inclined using the formula n equals 360 over theta minus 1. This is minus 1. Secondly, you'll be able to state the effect of mirror rotation on a reflected ray. Thirdly, you'll be able to solve simple problems on mirror rotation. And finally, you'll be able to state, that is number 4, you'll be able to state the use and practical application of what? Plane mirror. Now, let's see how multiple images can be formed in a plane mirror. Now, you find out that when two mirrors are placed at an angle to each other, an observer sees several images of an object placed in front of the mirror, and the number of images formed depend on the angle between the two mirrors according to the formula n equals 360 over theta minus 1. Formula very important. N, which is talking about the number of images we formed, is equals to 360 divided by theta. Theta is the angle of inclination between the two mirrors, minus what? 1. Now, let's see this. Now, let's look at this video. Now, looking at this video, you can observe your plane mirror, the first plane mirror. Then you have another plane mirror. Now, looking at this video, you can observe your plane mirror, the first plane mirror. You can see your second plane mirror. And we say that the number of images you formed depends on the angle of inclination. Now, these two mirrors are perpendicular to each other. They are inclined perpendicular to each other. Now, looking at these two mirrors, okay, here, the two mirrors are parallel. They are on a straight line. Now, you look at it. look at your objects, which is the optical pin. You place it in front of it. Now, what do you observe here? Okay. You have 1, 2. Let's look at the image. Look at them. They are inclined perpendicular. Look at the first one at an angle of 90 degrees. You have 3 mirrors, 3 images. 1, 2, 3. Okay, let's put them parallel in a straight line. The 2 mirrors will just be like a mirror, one mirror in a straight line. Now you place your optical pin in front, one image. Can you see the image? You have only one image. But when they are perpendicular, you have how many images? 1, 2, 3 images. So you can see that the number of images you are going to obtain when mirrors are inclined, 2 mirrors are inclined, depends on the angle of what? Inclination. Now, if the 2 mirrors are inclined at theta angle 90 degrees, how many images are we going to have? You use the formula n is equals to 360 divided by theta minus 1. We now substitute. N will be equals to 360 over our angle of inclination. Theta is what? 90. So 360 over 90 minus 1. Now, what do we have? 360 divided by 90 will give us 4. Minus 1, we have 3. So the number of images we are going to have when the angle of inclination between the 2 mirrors, theta is 90, we'll have 3 what? Images. Now, when theta is 180, what is the number of images you're going to have? You solve it the same way. You find out that when theta is equals to 180, you solve it the same way. You have 360 divided by 180 minus 1. And 360 you divide by 180, you have 2 minus 1. You have 1 image, as I showed you here. As I showed you from this place, the practical aspect of it. When the mirror was inclined, the mirror was placed straight. The 2 mirrors are straight, 180. You will have how many images? You're going to obtain only 1 image. Now let's look at the effect of mirror rotation on a reflected ray. Effects of mirror rotation on a reflected what? Ray. Now when this plane mirror is being rotated, remember once you rotate it, you have inclined it to a particular angle. We want to see the effects of this mirror rotation on a reflected ray when the incident ray is fixed. Take note. When the incident ray is what? Fixed. Now, let a ray be incident at an angle I to the mirror MNL. Now, look at this mirror. You have your mirror MNL, the first mirror, and this is your normal NP1 is your normal. Now, this is your incident ray NO, the incident ray. Now, when you rotate this mirror through an angle, you have a new mirror here, N and what? Y. That is, you have rotated the mirror now through a particular angle, theta. Look at another angle, theta. And once you have rotated this mirror through an angle, theta, now your normal will equally be rotated through an angle, theta. But before the rotation, remember our incident ray is fixed, which is your NO. And you have your normal, which is a straight line, NP1. Now, what is the angle of incidence? Remember, angle of incidence is the angle which the incident ray makes with the normal, and that is angle I. And now, when this incident ray strikes the surface of this mirror, it is being reflected back, according to our previous class. And remember, what is the reflected ray? The angle which the reflected ray, which is NRY, N1 mixed with the normal P, N what? P. So your angle of reflection is here, from here to here. Now remember the second law of reflection. Angle of incidence is equal to angle of reflection. Remember, look at angle of incidence from here to the normal, which is I. Then from that normal to the reflected ray is another I. So from here to here, I plus I will give us 2I. I plus I will give us 2I. Now when we rotate this mirror, here now you have X and Y. You have rotated this mirror through an angle theta. Look at it, theta. Now this, remember your incident ray NO is fixed. Now your normal will equally be rotated and you will have a new normal NP2. Remember the first normal was what? When the mirror has not been rotated, was NP1. But when we rotate this mirror, now your normal equally rotated through an angle theta, and the new normal is what? NP2. Now, despite the fact that the incident ray was fixed, it did not rotate, but for the fact that we have a new normal, the normal rotated, we have new angle of incidence. Remember, angle of incidence, angle which the incident ray makes with the normal. So here we have angle NO what? P2. ONP2. That is our new angle of incidence. And it will now be I plus theta, because our new normal we have theta and our angle of incidence was what? I. So the new angle of incidence will be from the incident ray to the new normal. So the new angle of incidence is I plus what? Theta. Now the reflected ray equally rotated, but incident ray was fixed. Remember, the reflected ray equally what? Rotated. Now your initially, when the mirror has not been rotated, our reflected ray was NR1. But now when we have rotated the mirror and our normal equally rotated to NP2, the reflected ray rotated to, and we have new reflected ray NR2. Remember, from that law of second law of reflection, angle of incidence will be equal to angle of what? Reflection. And our new angle of incidence now is I plus what? Theta. That means from the new normal also, you have new angle of what? Reflection. That is from here to here, which will equally be what? I plus what? Theta. Now, what is the rotation of the reflected ray? How long did the reflected ray rotate? That is from there to here. Now, how do we do that? You find out that the mirror, now let's see this. So you find out that by the law of reflection, that the angle of reflection is now equal to I plus theta. That is the angle between the incident ray and the reflected ray. Will now be equal to what? For incident ray, you have I plus theta. Please, this is theta, plus the reflected ray, as I've shown you in the diagram, we equally have I plus theta. Please, this is theta. And that will give us what? When you solve it, you have 2I plus 2 theta. So angle ONR2 will give us 2I plus 2 theta. Angle ONR2, let's see that. Angle ONR2, the total angle now, will give us 2I plus what? 2I plus 2 theta. That is 2 brackets I plus theta. Now remember, we want to see the angle of rotation of the reflected ray. How will the reflected ray be rotated? And remember, your incident ray is fixed. Now the whole of this angle for the angle for ONR2 we have 2I plus 2 theta. Now we are going to subtract it from here. Remember here, our incident ray, when the mirror has not been rotated, we have I, and our reflected ray, we have another I. So from here to here, we have 2I. So from here to here, we have 2I plus 2 theta minus from here to here, which is 2I, for us to get this angle of reflection of the reflected ray. Now let's see. Now, therefore, the angle of rotation of the reflected ray when the mirror is turned through theta, this is theta please, is 2I plus 2 theta minus 2I. 2I plus 2 theta minus 2I, and that will give you 2 theta. Take note, 2I plus 2 theta minus 2I. Let's see from that diagram again. From here we have the total angle ONR2. We have 2I plus 2 theta. Then minus 2I from here to here. And that gave us what? 2 theta. That gave us what? 2 theta. So this leads to an important result, that if the incident ray has a constant direction, that is, the incident ray is fixed, and the mirror is rotated through an angle theta, yes, theta, the reflected ray is rotated through an angle 2 theta. This is 2 theta. The reflected ray will be rotated how? Through an angle which is what? 2 theta. Now, this result is made use in certain scientific instruments such as navigators, sextants, or a mirror galvanometer, or in a mirror galvanometer. Now let's see this. Remember, we said that when the effect of mirror rotation on a reflected ray, when the incident ray is fixed, the mirror will be rotated, the reflected ray will be rotated through an angle 2 theta. Now let's see some examples. We have example 1. A ray of light, example 1. A ray of light is incident at 40 degrees to a plane mirror. What is the angle between the incident and the reflected ray? Take it again. A ray of light is incident at 40 degrees, that is angle of incidence, to a plane mirror. What is the angle between the incident and the reflected ray? How do we go about this? This is a plane mirror from the diagram. Remember, a plane mirror is a plain glass which one side of it is coated, savory coated. So this is the coated side, this is the plain surface side. So, and you have a ray of light that is incident to this plane mirror at an angle of what? 40. So this is the incident ray, ON. So ON is your incident ray. And the angle of incidence is how many? 40 degrees. Now, when this incident ray strike this mirror, the mirror will be reflected back through an angle NR. So, NR is your reflected ray. And the question says, what is the angle between the incident and the reflected ray? We know the angle of incident to be 40, but we want to know the angle between the incident and the reflected ray. That is the angle from here to here. Now, we only know our angle of incidence given to be 40. Now, from the second law of reflection, angle of incidence is equals to angle of what? Reflection. So, since angle of incidence ONM is 40, the angle of reflection NM MR or MNR will equally be what? 40. So therefore, the angle between the incident ray and the what? Reflected ray will simply be 2I, that is I plus I, or simply 40 plus 40, which will give us what? 80. 40 plus 40, which will give us 80 degrees. Or we say it is 2I. I is angle of incidence. That means for the 2I, 2 times what? 40. 2 times what? 40. And that will give us what? 80. Now, let's see another example. The angle between a fixed ray of light and a plane mirror is 20 degrees. If the mirror rotates through 30 degrees, by how many degrees does the reflected ray rotate? Now, this is talking about what we just discussed, the effect of mirror rotation on a reflected ray, which we say that once the mirror is rotated, that the reflected ray will be rotated through an angle theta. We say that if the mirror is rotated through an angle theta, when the incident ray is fixed, the reflected ray will be rotated through angle what? 2 theta. Now let's see this question again. The angle between a fixed ray of light and a plane mirror is how many? 20 degrees. This is talking about the angle of incidence, right? If the mirror rotates through 30 degrees, that is the mirror rotated through theta. How many? 30. But this 20 is talking about angle of what? Incidence. Why this 30 is talking about your theta, the angle of rotation of the mirror. Now, by how many degrees does the reflected ray rotate? Now, from what we explained on effect of mirror rotation in a reflected ray, we say that the reflected ray will rotate through angle what? 2 theta. So the mirror now rotates through 30 degrees. Therefore, the reflected ray will rotate through what? 2 theta. That is 2 times 30. So the reflected ray will rotate through what? 60 degrees. 60 what? Degrees. Now let's look at question number 3. Question number 3. Now let's see the question. Question number 3. The reflection of a narrow beam of light incident normally on a plane mirror falls on a meter rule placed parallel to the mirror and at a distance of 75 cm from it. If the mirror is rotated through 5 degrees, by what distance is reflected beam displaced along the meter rule? Please, let's take the question again for proper digestion so that you can know how to apply it. Let's take it again. The reflection of a narrow beam of light incident normally on a plane mirror falls on a meter rule placed parallel to the mirror and at a distance of 75 cm from it. Now let's see this diagram. Now this is my plane mirror. X and what? B. Now this is my meter rule. I place the meter rule to be parallel to my what? Mirror. This is my mirror when I've not rotated it. Now this is my what? My meter rule. This is my meter rule. You can see the label in meter rule. You can see your mirror. They are placed parallel to each other. Now, the reflection of a narrow beam of light. The narrow beam of light is incident normally. So look at the normal is a straight line, But now they say that the beam of light is incident normally, meaning that the incident ray will move straight. The incident ray will move what? Straight. It is still as the normal, but the arrow will show you is a ray. So incident normally is that incident ray will move on a straight line. Then they are placed parallel to the mirror at a distance of 75 cm from it. So this incident ray was placed parallel to the mirror from the meter rule. You can see the distance 75 cm. Now, if the mirror is rotated through 5 degrees, now let's see the mirror. We now rotate this mirror. You can see the rotation of the mirror, and the angle which we rotated the mirror is theta. How many? 5 degrees. Our question says, by what distance is reflected beam displaced along the meter rule? The distance the reflected beam will be displaced along the meter rule. Now this is the incident ray, which is also normal. Incident normally, when it strikes this mirror, it will be reflected back. Now what will be my angle of reflection? Remember, the angle of reflection will be 2 theta, and since the rotation of the mirror is 5, the reflected ray will be rotated through 2 theta, that is 2 times 5. So here I will have how many? 10 degrees. This angle here will give me 10 degrees. Now angle ONR will be 10 degrees. As I've told you, ONR will be 10 degrees. Now when NR represents the reflected ray, so look at it, NR reflected ray, after the mirror has been rotated through what? Rotated through theta, ONR. Now we look at it this way. Tan theta is equals to what? Opposite over adjacent. And opposite to this angle 10 is OR. Now your hypotenuse is NR, while your adjacent is NO or OM. So we have that. And what are we looking for? Go back to that question. By what distance is reflected beam displaced along the meter rule? And look at the reflected beam here, right? And look at your meter rule. So you're looking for OR. Is that clear? We are looking for OR. So using tan theta to be opposite over adjacent, which is tan theta is equals to tan 10, that is 10 is a theta, is equals to opposite to the angle, which is OR, over the adjacent ON. We are now looking for OR. Do cross multiplication. Tan theta will give you OR over 75. That is your ON is 75. We make OR the subject. OR will give us what? 75 times tan 10. 75 times tan 10 is 0.1763. So OR will give us 13.22 centimeter. So you find out that the distance which the reflected beam is displaced along the meter rule is how many? 13.2 centimeter. Now we look at the use and application of plane mirror. Where do we apply plane mirror? Where do we use plane mirror? Number one, plane mirrors, we use them as what? Looking mirrors at home. That plane mirror we use in our demonstration, you can equally use it as your looking mirror. That plane mirror, you can use it as your looking what? Mirror. So look at this plane mirror. When you look at it, you find out that you can see someone, you can see me holding it. So it is, you can use it as your looking what? Mirror. So we use plane mirrors. They can be used as our looking what? Mirror. Then another use of plane mirror, we use them as driving mirrors in the vehicles. Then we can equally use them in optical testings. Then we can equally use plane mirror in making some instrument like your kaleidoscope and your periscope. Kaleidoscope is just a toy which you can use to get several images when the two plane mirrors are inclined at how many? 60 degrees. When you incline the two plane mirrors at 60 degrees, you can get your kaleidoscope. You can get multiple images. Now let's look at the simple periscope. We can use plane mirror in making our simple periscope. Now the simple periscope is an instrument that enables an observer to see over the head of a large crowd or over the top of any obstruction. They are used in warfare and in submarine navigation to enable the observer to see whole remaining hidden or submerged. The mirrors are a periscope, allow the observer to see objects that are not in the direct line of vision. So you can see the image of your periscope. So we look at this periscope. We use it to view obstacles. It helps the observer to see above your obstacle or above a large crowd. Now, during the time of Zacchaeus, we know that Zacchaeus was a short man according to our Bible. And had it been when Zacchaeus wanted to see Jesus, there was a large crowd. He was struggling to see Jesus. But had it been Zacchaeus know about this periscope, he would have constructed one periscope, and where he stays, he can use it to observe. You can use it to see Jesus. Use it to observe above the large cloud. How do you construct your periscope? Periscope consists of two plane mirrors fixed facing each other at an angle of 45 degrees to the line joining them. Now your plane mirror, you've made your plane mirror to be inclined at 45 degrees. You incline the two mirrors at 45 degrees. They will be facing each other. Now a horizontal ray of light from the object O will fall on the mirror M at an angle 45 degrees to the normal. As the angle of incidence is equal to angle of reflection, the reflected ray AB from your M1, that is the first mirror, is at right angle to OA. Now this ray will strike the mirror M2, that is the second mirror, also at 45 degrees to the normal, and is similarly reflected along BE at the right angle to AB into the eye. Thus, by the reflection of two plane mirrors, an object hidden from view can be seen by an observer. Now, let's see from our diagram. Now look at the object. That is something you wanted to view that was hidden as a result of an obstacle or large crowd. Now this is your plane mirror M1. Now this is the second mirror M2. The two mirrors are inclined at angle 45 degrees. Now this is the incident ray from the object you want to view. Now look at the person viewing it. Look at your eyes here. Now the incident ray, on striking this mirror at angle of 45 degrees, it will be reflected. Now it will be reflected. This is the reflected ray, reflected at 45 degrees, also striking the surface of the second mirror M2. And when it strikes this second mirror M2, this reflected ray equally serves as the incident ray to the second mirror M2. Now the mirror will now be reflected back. Now look at the observer's eye. The observer will begin to view the image. You begin to see that image here. Now remember, this is the object you want to see, which is above an obstacle. Which obstacle was obstructing or above a larger crowd. This is the object you want to view that was being obstructed. And look at you here, your eye. Now, as you're viewing it here, you'll be seeing that object here. This is the image of the object. So we use this periscope. It enables us to see above a large crowd or above an obstruction. Now, that is your periscope. And the major disadvantage of this periscope is that it often produces multiple images. It normally produces multiple images. Now, this comes to the end of our today's class. So today we have seen the effect of mirror rotation on a reflected ray. And we have equally seen that number of images can be formed when two plane mirrors are inclined at a particular angle using our formula n equals 360 over theta minus 1. Remember, n is talking about the number of images, while theta is talking about the angle of inclination of the plane mirrors, whether they are inclined at 30 or at 60 or at 90 or at 1/8. You will use the formula to see the number of images will be formed. Now, assignment number 1. If the angle of incidence of a ray of light on a plane mirror is 40 degrees, the deviation of the incident ray after reflection is dash. You have to solve it. Remember, we talked about deviation, how the ray has been deviated. D, deviation is equals to 180 minus 2i in our last class. Now, number 2. Two plane mirrors are placed so as to incline at an angle of 150 degrees. Calculate the number of images of an object placed symmetrically between them. Thank you once again, my participants, wherever you're participating from. Thank you once again. Remember, our class continues.